Welcome everyone. My name's Malcolm Eadie. I'm the Commercial Manager at the CRC for Water Sensitive Cities, and I'll be the MC for today's event. Thank you very much for giving us 45 minutes of your time to listen to our launch of the Urban Water Cycle module in the CRC's scenario tool. The scenario tool is one of the flagship products of the CRC, and we're very excited that the Urban Water Cycle module completes the core functional modules that are to be included in that tool. And after some considerable internal development of the water cycle module and some testing and validation, we're now ready to launch that as a beta version for CRC participants to start to apply the tool and the module in particular, and give us some feedback as part of that process. So the scenario tool is as I say, it's a flagship product of the CRC, and its intended purpose is to really support collaborative interdisciplinary planning at a suburb and city scale. And the tool includes a series of functional modules, including the Urban Water Cycle module we will be releasing today, but also modules covering urban heat, land surface temperature, air temperature, human thermal comfort as part of that analysis. And it enables the scenarioing of urban development and infrastructure solutions to be tested rapidly as part of that collaborative planning process. So it's an exciting tool to really drive water sensitive cities thinking at an early stage in a city's planning from both a built form and infrastructure perspective. So as I say, we're very excited to have the Urban Water Cycle module now ready in a beta form to be used by our participants. And today, the structure of the 45 minutes is we've got 3 speakers lined up. Luke McPhail from Water Technology will talk just briefly from an industry perspective around where the value is for the scenario tool within industry and some of the potential uses of the Urban Water Cycle module. Luke is also the chair of the project steering group for the Tools and Products program of the CRC, so he's very intimately knowledgeable and involved in how the tool has been developed over the last couple of years. So I'll hand to Luke shortly. Following Luke, we'll just have a short presentation from Steve Kenway, Associate Professor Steve Kenway from University of Queensland. Stephen is the research leader of our infill evaluation project, so looking at water sensitive outcomes from infill development, and Steve's program has developed some frameworks for evaluating the performance of infill development and some tools to support the application of those frameworks. And Steve will just give a very short oversight of the outputs coming from his project. And the reason for having Steve on today is the water cycle module within the scenario tool is one tool that can be used to provide inputs into the infill evaluation framework that Steve's program has developed. And then finally, Christian Urick, Dr. Christian Urick from Monash University, who's led the Tools and Products program within the CRC for the last 4+ years and is the lead developer of the scenario tool and the Urban Water Cycle module, will be presenting how the module works via a couple of case studies. So Christian will have the floor for the majority of today. If you have any questions or statements that you'd like to sort of communicate through the course of today's session, please use the chat function at the bottom of your screen. What we'll endeavour to do through the course of the event is have some short breaks and see if we can actually address a couple of those questions along the way. If there's not enough time for that, we'll collate all of those questions at the end of this session and endeavour to get back to each of you subsequent to this particular session. So once again, thank you very much for joining us. I'll now hand over to Luke, and Luke, if you can just give us a brief industry perspective.
Thanks, Malcolm. Firstly, congratulations to the CRC, Christian and the team on this significant milestone. From my experience, product development is never easy. Converting the science into a usable tool is a challenge, and it's fantastic and quite timely that we've been able to get this far. So well done, guys. Looking back, the early intervention iterations of the scenario tool allowed us to develop cooling strategies for the urban environment. The refinement and implementation of the urban water cycle module really incorporates an important layer of information that allows us to assess and compare multiple user-defined urban planning scenarios. And from an industry perspective, bringing together these key elements of the built environment, including form, density, extreme heat, thermal comfort, blue-green infrastructure, and now the urban water cycle, provides a unique opportunity to understand the urban planning and development implications, as well as the appropriate management solutions. Solving these issues in isolation can be cumbersome, and bringing it all together in one platform is a real game changer for the industry. These earlier modules allowed us to build an understanding of the urban heat impacts, how blue-green mitigation strategies can improve the urban environment. But now with the overlay of the new water cycle module, it allows us to explore, analyse and optimise urban water cycle responses to these interventions, to understand the changes in the urban form, demand and runoff changes, just to name a few. As an example, if we increase the irrigated surfaces to mitigate against urban heating, what are the water demand implications? What are the differences at a lot, precinct or catchment scale? This allows us to actually explore these urban water implications quite considerably. As a near real-time planning tool, this provides a platform to understand the multiple dimensions, challenges and opportunities that are presented in the urban environment. And for me, and I know for many, it's quite exciting. Getting to this stage, it provides us a platform to explore these integrated urban water management challenges, bringing together the multiple layers of information, supporting a collaborative decision-making process. And one of the key things that are coming out of this new module is improvement in communication of complex information to a wider audience to aid with that decision-making process. Again, well done. Congratulations. And I'd recommend everybody to actually look into the tool as it becomes released, and I look forward to using it in the projects that I'm involved in. Thanks, Malcolm.
Thank you very much, Luke, and thank you for your considerable contribution over the last few years to the development of the scenario tool and the industry insights you've brought to it, which I think has really positioned the tool nicely to have great impact when used effectively by industry. So thank you very much. Steve, I will throw to you now. If you could just give the group a quick overview of what's coming out of the IRP4 program.
Sure. Okay, to share my screen briefly. Oh, actually, I can't share my screen for some reason. Are you able to enable screen sharing, or maybe that's been set up? I can just talk then. For those who don't know, IRP4 is about water sensitive outcomes for infill development. So we work with a very good steering committee across the country for that. That it's really been set up to look at the poor outcomes that are occurring with infill development, whether it's increased runoff causing downstream flooding, reduced evapotranspiration, reduced cooling, loss of green space, etc. within cities. And also it was set up to deal with inadequate current performance evaluation frameworks. And so the scenario tool is very helpful for dealing with a lot of those things. And particularly now it's got the water balance module as a ready source of information on water flows within cities. So perhaps one of the unique things that's happened within the IRP4 project is that we create a volumetric, a three-dimensional water balance for an entity, for a three-dimensional entity, and quantify all flows into it and out of it, not just the supply-demand balance, but all flows of evapotranspiration, stormwater infiltration. The IRP4 project has used that in case studies in Knutsford, in Perth and Salisbury to apply a range of tools, including our water balance tool, which we've just about to release to, I think, Malcolm. I'm not sure exactly when the release of that will be, but an Excel-based site scale water mass balance tool and user manual. The framework is already on the CRC on the IRP4 website, the draft framework. The final framework will be up in the next few weeks. It's just going through the final approval from the CRC, but the work for that is finished, as is the Salisbury case study. The Western Australian case study is probably 90% finished, going out to the steering committee very shortly for final review, etc. So I guess, yeah, the scenario tool is a good way for evaluating performance, and it's worth having a look at the evaluation framework, which guides what are the indicators that you'd select in different locations. How do you consider all flows? How do you define the entity, or what is the development when you consider the buildings, the architecture, the soil, the land, the natural rainfall, and how do you relate that to the natural conditions of that site? And the case studies give application examples of that. So we've got a fair bit of product from that project, which is some released already and a fair bit which will be coming out over the coming 2 to 3 months. Thanks, Malcolm.
Thanks a lot, Steve. And as a lot of the research projects of the CRC near completion now, and the products and the frameworks and the guidelines that have been developed within those are all reaching maturity, there's a lot of effort happening within the CRC now to ensure that the various tools and products that have been developed through those research programs are integrating and able to actually add value to one another. So there's a bit of work going on at the moment within the scenario tool to really nuance the user interface and the dashboard and the way in which analysis results are summarised and presented so that they're fit for purpose to be able to provide direct inputs to, for instance, the evaluation framework that's coming out of the IRP4 program. So I'd encourage everyone to familiarise yourself through the CRC website with the latest products and materials that are flowing through, because the value is how these integrate as a sort of an integrated suite across the process of urban planning and development. So I'm just checking whether we've got any questions come through in the Q&A or the chat, and we don't at the moment. So I think what we might do to give Christian plenty of time to walk you through the urban water cycle module. I'm going to flip to Christian now, and I think he's going to share a screen. So it's over to you, Christian.
Can you hear me? Yeah, cool. Turning on the microphone. I should know by now, I guess, after being home working for 6 months almost. Okay. Yeah, so it's quite exciting to really show you today how some of those elements that you probably have long been waiting for are coming together. And I want to give you today a bit of an overview of the scenario tool first for those that haven't seen it yet, and then through a few use cases, discuss a bit the potential of the urban water cycle model. And for some of the detail, probably going to refer to the documentation and that we have, and also there's going to be a training next week. I'm going to mention that at the end as well, but if you're interested in that and getting more hands-on experience, please join us then there next week. I also want to acknowledge here we've done lots of testing in the past few months. There was an internal testing group within the CRC, so with the Water Sensitive City Institute. Big thanks to that team, as well as then to a core team of testers that we have, which is Luke Medhadi and Dylan helping with that, and then also then a broader testing group. And we've taken really this feedback on board and have hopefully made quite some substantial improvements to what you have previously seen, and I'm quite excited to show you that today. Now, just in terms of the what is the water sensitivity scenario tool? So ultimately, it is meant to help you evaluate and design concept solutions and policies. So it's not really about looking into bits and pipes and the nuts and bolts of a system. It's basically getting an understanding what potentially could work well, and really helping to filter out and pre-scan some of the solutions that you might be looking for. The tool itself is supporting to help you to assess the multiple benefits that we see through blue and green infrastructure systems. And there's a nice picture here. I think that's for Fisherman's Bend here. There's if we take water sensitive urban design to that next step, there's just lots of opportunities for blue-green corridors, green spines that have an impact obviously on the water system, but also on the microclimate. And it's really about understanding how those systems can interplay to really increase the resilience, sustainability, and livability of a place. We also want to support scenario planning and testing. So it's really be rapidly being able to look into different ideas and exploring those, as well as then a more collaborative element. So it's kind of, we've seen the tool comes with some visuals, maps and so on. It really should help with communication of some of the results. They could be traditionally quite technical, and we hope with the visualizations it makes them more easy accessible to also to non water professionals as well. And then feeding into other tools as well. So as Stephen already mentioned, it's a fantastic evaluation framework that IRP4 developed for that large scale and small scale development. So being able to support that, help with upscaling that, and then also feeding in some of the economics tools that the CSC has developed to really provide you a basis to make a business case. And then also this is something that is close to my own work, being able to bridge between data and models more fluently. So it's traditionally quite difficult or quite complex in terms of just data management, bringing a lot of those elements together. And we want to make it as easy as possible so that you can start working with those tools and models to get started. Okay. Now the tool itself, and here's something, probably one of the iterations that you see now, is a web-based tool. So you can access it through a website, and the link, I think, is at the end, then again. And then you can interact with the map that we see here. We've also been working on simplifying the user interface and the results. So you might remember, for those that have used it, there was quite a massive dashboard further down with lots of details. So in the last few weeks, we have developed here a bit of a simpler way of how we can communicate some of those results, and also the detail is still there. You can reveal it if you're interested in, but give you quite a high-level summary. What it is there today as well, it gives you then these graphics around the water cycle model, as well as I said, if you're interested in the need to know and the details, really giving you detailed information about climate and other details that you're interested in. So this is the tool itself, how it works. And you can have this big, large map as well, and can, at the moment, probably collaborative settings, at least in Melbourne, are a bit challenging. But it's actually quite a nice way as well to engage with some of the issues. If you bring up the map, can interact with it, look at that, look at some details, and even explore some of the scenarios online. Now, one of the elements that I talked about before is really bringing those data in and bringing that closer. So we have been integrating here data sets based on Geoscape. If you haven't seen that, they have building footprints and land cover for all of the urban areas in Australia. And you see here a snapshot for Melbourne. So this has been quite a helpful step for us to really being able to provide a product at all of the, for all of Australia, basically. It also includes open data that are available. It might be elevation data, soil data, and so on that you might need for your modeling, as well as then socio-demographic data. So this is your ABS data that we can use then to make estimates around populations in individual buildings, as you see here. Climate data as well. So this is then really just starting to feed into the model. So this is your Bureau of Meteorology rainfall data, but also temperature data, wind speeds, and so on that we need, so for example, for the microclimate tools. Now, those models have been set up in terms of this beta version that you have available at the moment for Melbourne, Brisbane, Perth, Adelaide, Townsville, and Sydney. However, if you're interested, and if you're not listed in here, the Water Sensitive Cities Institute has a license, as I said, for all of the Australian urban areas. So we can look into setting up those regions then for you as well, if there's something that you're really keen on to explore. So this means in these areas, as you will see, the tool basically are ready to go with modeling if you have a license for that. But you're also able to bring your own data. So we not completely rely on those data provided here by Geoscape. You can mix and match your own data if you need. Now, this is the first step. So how that looks in the tool. So this is one of the developments that we're looking at later. So basically draw up your catchment boundaries. And then with the tool, basically populates your case study with the data that it has available. And then you can immediately run, in this case here, a land surface temperature assessment to get you the initial information about the different land cover use in that area. So quite helpful in that sense. Now from here, you have different models that we can use. And this is here an example for greenfield developments. So there's typical developments in the growth areas, for example, as well as infill developments as well. So you can simulate densification of cities and look into different urban form typologies there. So what would that mean and how that looks on the ground? And that's also then accompanied by infrastructure placement. So you can place green technologies or rain tanks or trees and assign that to different parts of your case study area and then understand what those impacts are. And then what we have in the models is then basically land surface temperature is available to everyone. We have target, the microclimate model, which has been released. And today, this is what we're going to talk about, is the urban water cycle model. And I want to dive into that a bit more. So basically for the urban water cycle, what has been important, and this is some I think, early work out of 2006. So we're looking at a natural water cycle. Here, so we have a lot of limited runoff, a lot of infiltration and evapotranspiration. If you go into the traditional business as usual urban water balance, what we find is here then the shift obviously. So it's kind of, we have basically water running through that city. A lot of it is going to be runoff. A lot of it is going to be imported water, so coming from the mains as well as wastewater discharge, and then reduced infiltration and you reduced evapotranspiration, which is then crucial, for example, for urban heat issues. And this is what we want to ultimately get to, is that so water sensitive urban design or water sensitive city mass balance, where we reuse a lot in the system to minimize this import, can increase infiltration again, can increase evapotranspiration. So we have that available during hot days. Now, the background to the model itself. The model itself is a conceptual model. So this is, if you are familiar with those, so these are models like music, models like source. So they're conceptual models. And this is a process how such a model looks like, but you don't need to be afraid. I'm not going to go through that in detail, and also in the model. This is what the scenario tool does in the background. So it builds those models for us to run then the analysis. The model itself can run on a flexible timescale between 6 minutes and 24 hours. So you can set that, and you can run from one to multiple years. So that depends a little bit on the scale of case study that we're looking at. It considers, here I should mention as well, that it builds on those traditional urban, so catchment models that we have in Australia, for example, that music are based on, as well as that are integrated into aquacycle. So they provide the basis for that. The model itself works on a lot scale. So basically builds a place or a case study up from a lot and considers here, for example, the different areas that we have. We have irrigated areas. This might be a garden or irrigated turf. Might have a building on it where you have roof that has people living in that. And for those, we estimate the demands based on demand profiles that you get. We have the impervious areas out of driveways. We have unirrigated surfaces there as well. One particular component, the irrigation demand, is also estimated depending on evapotranspiration and soil moisture levels, so there's some flexibility in that. From here, we consider in total 11 streams sitting on lot. And this is quite a complex diagram, but it's just to show you, basically, this is the system, how it operates on lots. It ranges from potable to non-potable demands to your impervious runoffs, and so on. Now, why do we consider all those individual streams? So this gives us a powerful way of then rewiring the system. So that means you can slot in, for example, a rainwater harvesting tank, capture that roof water, and feed it back in for non-potable use or for outdoor demand. So it gives you lots of flexibility. And those things are then scaled up further. From here, then, as I said, we can intercept those streams and then consider multiple different storages. So there might be your rainwater harvesting tanks that provides use for multiple purposes, so for your outdoor and for your non-potable use. You can also add a grey water tank as well as a stormwater system to that. So the water cycle model has that flexibility to consider storages in sequence or in parallel at that lot scale. But then also you can rewire the system then to be working at that subcatchment scale. So for example, if you have a residential subcatchment, an industrial subcatchment, and a sports field. So you can, for example, harvest that water, the stormwater or the wastewater, so the stormwater coming from the residential catchment, and use it as to provide irrigation water to the sports field. Or you're also, for example, able to implement a sewer recycling scheme and provide that water back to the residential units to be used as outdoor for irrigation as well. So there are multiple ways of how you can rewire and set up that system. Now this gives us a lot of flexibility, so we can cover here a range of use cases, and this is one example here for Fisherman's Bend, where we can see those systems can get quite complex. So we have multiple reuses at different scales. And this is what we were aiming for, that we actually can cover that and being able to look into some different ideas and solutions for those. The model itself scales from precinct to city scale, and we're going to have a few examples for that later on, what that means. And it also is it's really the focus of it is designed to test concept designs for integrated urban water management. So if you really want to go then into your pipe designs and some of the other tools that are far more detailed and do that really well. So we want to really be more at that high level, but being able to explore that. There's also this element, this is here, which we're currently incorporating. So it gives you also a visual way of how you can communicate the water cycle and see how those elements are changing. So those outputs are produced by the tool, as well as if you're interested in storage behaviors and time series and so on, you can start to drill down deeper in the charts that the tool provides. Now, some of the applications here that I would like to show you now. So I have basically 3 applications, and I want to start with a typical greenfield development. So this is what we obviously find a lot in the outskirts of our cities. Now we start basically, this is now in Melbourne. I think it's in the west, basically one of the areas. Now we have here a new residential area coming in. We have an industrial area. We have some schools in that little catchment as well as some green and open spaces that we need to provide water for. We have a road running through, as well as then some unirrigated open spaces as well. Now you can now use the scenario tool if you set up the rules for the individual zonings here to create the urban form for you, which is so we are not providing, we're not aiming to create a tool for urban planning. So this is not the purpose of it. But what we are after here in this case is the messing of the urban form. So how much roof areas, how many people are living in there, getting those values right. And also the ratios between pervious, impervious, and irrigated spaces. So this is the basis for the water cycle model. From here, if you run the model now, you would get the typical urban water cycle that we see. From here, we basically have imported water. You can see there's lots of rainfall coming in on top. So huge of potential for rainwater harvesting. Now we put in rainwater harvesting here, for example, in the residential areas, and can then observe how this would change the water cycle. So obviously it would reduce the imported water demand as well as starting to change the runoff. From here, another option would then be starting to add a water recycling scheme. So in this case, we collect the water from the residential area, the wastewater here, and provide it back to the industrial area. Then can also have a look in that, see what is the effect of that, so how much wastewater can we capture. So this is just giving a bit of a snapshot of how they would operate at lot scale. And there are lots of different ideas that you can explore. Then for Fisherman's Bend, this was a more complex case study in that sense. So we started here again, building up the model. I've seen those before, and then going into one of the smaller precincts here. So if we develop that up, so we put in the PSP and the zoning rules and get the building messing. Now for here, we've also applied different tools as well to just give you a snapshot of those. So there's the land surface temperature modeling coming in, which is going to help you to identify some heat hotspots at the first glance. And then from here, we can also run the air temperature model, which gives you a bit of an idea about human thermal comfort and how well is your case study performing. So those models are running at the same time as your water cycle model is running to get that integrated assessment. And that gives, for example, for the air temperature is over 3 consecutive days. Now, if we look at the water cycle, this is the water cycle as it would look like for this particular precinct. Now, obviously, in contrast to the more low density development areas here, it's really the imported water. So the water that's coming in from the potable system, which is the main component, whereas precipitation and runoff are obviously much smaller in relation to that. So from here, now this is then starting to explore what we could do with water recycling. And one of the first options is starting to look into rainwater harvesting. And the rainwater harvesting here is more a measure of stormwater management. So for example, reducing peak runoffs. And we can see here, it has limited success in actually reducing the overall water. But we can see when we look at the actual storage tanks, how it really can filter out and helps with reducing some of those peaks when they come through the rainfall. We also then have here the other example where we started to put in a precinct scale water recycling plant where we actually start to recycle wastewater for non-potable use here. And you can see what massive impact that would have in this system here. Okay. Now I want to go to the next scale. So this is we are just working at the moment with the Water Sensitive Cities Institute, Townsville City Council and E2 Design to really bring that also to the next level. There have been quite a few breakthroughs on making that, to make that happen in the last few weeks. So basically this is now looking at all of Townsville. And this will be basically a rough first assessment of the water cycle that we would see here. Now, what we did was also adding, for example, a water recycling scheme. So really pointing out, and this is what's happening in Townsville at the moment, there's some wastewater recycling to provide that for irrigation, for golf courses and other public spaces. And then being able to assess that, what that does in terms of the overall volume. So you can mark up those areas, say you want to irrigate that and connect that up. The model would give you those results. From here, we're interested in how would Townsville then change into the future. And we have set up the model then to go from sorry, this is just a side note also, if you're interested in running the heat assessments, we have basically been able to scale up target to provide an overall assessment now as well. So this is for those that are familiar with that model. It's quite useful now to really run at those large scales as well. So this is when we look at Townsville today, 2020. So what we did here was putting in the zoning regulations, and I just jump it between back and forth a little bit. The zoning regulations for today's planning, as well as then the future population projections, and it covers greenfield, infill development, as well as high priority development areas, as you probably can see. Now from here, we can assess impervious fraction changes. So you see how those things are changing on the area, as well as then changes in the air temperature as well. So you can really assess that and see how those heat hotspots are emerging. But what we want to discuss today as well is that we actually can see also how that's affecting the water balance now. So it's kind of in this case, we, for example, see obviously the increase in runoff. We see an increase in water that we always need of from the mains, but really important also that goes back to the wastewater treatment plant. And on the other hand, which might be interesting, slight increase in evapotranspiration as well, because we're adding new areas as well where we have, the lots are quite large and we use quite a lot of water for irrigation, which is then basically reflected in the model. Now, I hope that gives you a bit of a feel for the tool and what you can do with it. There's a training that we're going to provide next week on the 9th of September, and we're going to work through the greenfield case study there with you to give a bit of an idea of how you can actually set up and work with those models. And I hope you join us there. And if you have any other questions, just get in touch with us, and we're more than happy to discuss any application or any other questions that you have. Okay, please email Tamara Holt or get in touch with your regional managers for more information on the training. Thank you.
Great. So thank you very much, Christian, for running through that for everyone. I think that was really clear as to, you know, the development process that's led up to where we are. It's been very significant, and the various scales to which the urban water cycle module can function at, from lot to subcatchment to whole city, is really exciting. So thanks, presenters. We've had 3 questions come through. So what I might do in this last few minutes is just go through those 3 questions, and I'll ask one of our speakers to respond to each one. So the first question was from Dale Robinson, and the question was, can the urban water cycle model complete a water balance for an urban lake system? So look, I'll probably throw that one to you, Christian, just so that you can kind of talk through the sort of the accuracy to which the model gets down to in relation to individual storages.
Yeah, so at the moment we have it, so this is basically a first version that we're releasing now, which is only consider basically typical storages that we have. So lake systems are not part of that yet. This is something that we're looking into for potential future improvements, that instead of just basically adding a storage, you can also then say, look, you want to add a wetland there, or you add a lake system. But at the current form, it is not there yet.
Okay, thank you, Christian. Second question came in from one of our own, Chris Tanner, our Queensland Regional Manager, and he's asked, can the user vary the demand profiles, or are they hardwired in the group?
Yeah, so we have daylighted all those elements in the tool. So you can change your demand profiles, you can change your cell profiles, you can put in the time series that you're going to look at in terms of your rainfall. So all that is available to the user to customize that.
Thanks, Christian. The final question that's come through is from Marnie Island. Thanks, Marnie. These models are great feedback, love that. Question is, can they extend to catchment corridor scale applications? And I guess that question came in just before you presented the Townsville analysis, Christian, but I'll throw to you, Luke, if you want to just answer that one.
Yeah, look, there's great flexibility in the scale, the spatial scale that you can go to from lot through to whole of catchment. So that certainly is accounted for within the model.
Yeah.
Okay, thanks Luke, and thanks everyone for joining us today. Appreciate you giving us 45 minutes to hear where we've got to with the scenario tool and the urban water cycle module. So as it stands now, the scenario tool with the functional modules that Christian's presented is available in a beta form for all of the CRC participants to now access and use and apply, and we'd encourage you to do that. For as many use cases as you think you can apply it to, the feedback that the CRC can get from users of the tool will be invaluable over the next 6 to 9 months as the CRC comes towards completion. So thanks very much for joining us. I really do encourage you to access and use the tool. And if you're interested in the training that Christian mentioned, please, I think you've got to register for that training, and if you need to do that, there's a link I think that might have been shared in the chat. If not, you can contact Christian directly. I'm guessing, sorry to drop you in there, Christian, but
no, that's all fine. Yeah,
really encouraging you to attend training to really get under the bonnet of the tool and become one of our early super users. So. Yeah, thank you very much, everybody, and enjoy your lunch and the rest of your day, and we look forward to seeing you all again soon.
Thank you.